Hey guys, welcome back to another Further Pure 1 revision video. Today we're taking a look at inequalities. So one of my favourite chapters, or one of my favourite topics in this textbook. You know, it's quite a good kind of like problem solving topic. So let's take a look at what we've got. So in this chapter there's essentially three parts to it. So it's solving inequalities using graphical methods, so using graphs, solving them algebraically, and then solving inequalities involving modulus signs. So this first question here is a graph question. So if we are looking at this one here, so this is from exercise 4b, we want to solve this one graphically. So the first part is kind of helping you walk your way through it. So we're asked to just sketch the graphs of y equals x minus 1 and then y equals 4 over x minus 1. So hopefully it's nothing too difficult. Certainly the y equals x minus 1 shouldn't be anything too challenging at all. So if I just kind of draw it over here, just so we've got a bit of room after. So if we draw the easy one first, y equals x minus 1, so that's just going to be a straight line. Where will it cut through the y-axis? Well, it's going to cut through at minus 1, okay, when x is 0, so that's minus 1, so let's just say that's there. And where would it cut through the x-axis? Well, it's just going to cut through the x-axis when y is 0, so that would give you x equals 1. So let's just say that's there. Okay. If you just draw a straight line through these points, we've got a rough sketch of it basically. So something like that would give us y equals x minus 1. Now, this y equals 4 over x minus 1 is a little bit more complicated. You need to consider what type of graph this is. So y equals 4 over x minus 1. Well, this is a reciprocal graph, right? So it's going to look something of the form, something like this. Just to give you a rough idea, something along that kind of idea. So how do we actually sketch that? Well, consider the asymptotes. So, for example, if this was y equals 4 over x, where would the asymptotes be? Well, we'd have one at x equals 0, and we'd have one at y equals 0. Okay, it's just a standard reciprocal graph. Nothing's really happening apart from the stretch here. So at that point, it's just x equals 0 and y equals 0. Now compare that to the reciprocal graph we're working with for our question. We've got this minus 1 here in the denominator. So remember, this minus 1 essentially acts as a translation for the graph, okay? So what we're actually doing is we're shifting everything 1 unit to the right, okay? So the first thing to know is we're going to have this asymptote here. X equals 1. Okay, so that's the first thing to know. And now, if you actually consider just drawing the graph, it's not too bad. The only other thing to consider is where it's going to cut through the y-axis. So when x is 0, it's going to be 4 divided by minus 1, so it'll cut through at minus 4, say. Let's just call that there. So now, we can sketch this. So remember, it would normally kind of come down here, because we're shifting it to the right, it's going to be along this asymptote here. Remember, it doesn't touch this asymptote, it's going to be very, very close. So it might look something like this. Okay, just to give you an idea. Again, I'm doing this rough on a tablet, so it's not the easiest to draw, but just so you get the idea. And then if we sketch the other part of it, so that'll be over here. And remember, it cuts through at minus 4. That was terrible. Let's just redo that. So I've drawn this pretty bad. Something like that. And again, it'll kind of go along down here on the asymptote. So my graph is pretty bad, but it's roughly kind of what it should look like. If you draw it near, yours should look a lot better than mine. So part B, we want to find the points of intersection of y equals x minus 1, so our straight line here, and then our reciprocal graph, y equals 4 over x minus 1. So nice and easy. If they're both y equals, then they're going to be equal to each other as well. So equating them now, that's x minus 1 is equal to 4 over x minus 1. Multiplying through here by x minus 1 equal to 4. Expanding this, I'm going to get x squared minus 2x plus 1, is equal to 4, and then subtract 4 off both sides here. So we get x squared minus 2x minus 3 is equal to 0. Okay. And then at this stage, we just need to factorise, or we hope it factorises, which it does quite nicely. We get x minus 3 and x plus 1 is equal to 0. Okay, so we get 2 points here for my x coordinate, so we get x equals minus 1, and then x equals 3 here. So now, we want the actual points. So now we've got the x coordinate, we need to now work out the corresponding y coordinate. So when x is minus 1, you can just substitute into either of your two equations. The easiest one would be the y equals x minus 1. So when x is equal to minus 1, y is equal to minus 1, which is minus 2. Okay, so that first point there is minus 1 and 2, sorry, minus 2. And then this one here, y is going to be equal to 3 minus 1, which is just 2. So then that point there is going to be 3, 2. So then we have 2 points here of the intersection of y equals x minus 1 and then y equals 4 over x minus 1. And then finally for part B, we just need to write down the solution to the inequality x minus 1 is greater than 4 over x minus 1. So this way we need to just use the graph to actually solve this. So what we're looking for is essentially where does the line y equals x minus 1, where does it lie above the reciprocal graph? So if you consider, so let's start with this quadrant here, it's a bit easier to see for this one I think. So where is my straight line above the curve, or our reciprocal graph here? Well, hopefully it's clear to see that at this point here it's just everything to the right of this, okay? This line is going to keep going on like that, and this reciprocal graph is just going to keep going closer and closer here to the x-axis. So everything past this point here, whatever that coordinate is there, that's going to satisfy it. And then also similarly down here, where is the essentially where is the line greater than the reciprocal graph? Well, hopefully it's clear that it's going to be everything to the right here, like so. Okay, so again that's where that intersection is there. So let's just note down which one's which. So this one has got to be positive, so that's clearly got to be my 3, 2 here. So that there, we call it A. So A is 3, 2. And then if I call this one B here where they intersect, so that's B. And B is minus 1, minus 2. So if we write this down now as an inequality here, for where it does satisfy it, so therefore it's got to be between this point here where this starts, so that's going to be x equals minus 1, so that's minus 1 there. And it's going to go to the essentially where the asymptote lies here at 1. Okay, so the first part will be minus 1 to 1, and then my other solution here is everything past this point. Well, if this is 3 on the x-axis here, 3 units, then everything to the right of this, everything greater than it, will also satisfy it. So we can also say that x must be greater than 3. So there we have it. So that satisfies our solution there for the inequality. So moving on to the next question here, we've got a question where we're solving it algebraically. So this one's quite I'd say quite an easy one, and the reason for that is because our right hand side of the inequality is just 1. Okay, so the denominator again is just 1. So let's just write it down. Greater than 1. So like you would with solving any algebraic inequality of this type, we multiply through by x squared. Okay, and we do that to ensure that we don't have a negative there, because we wouldn't know whether we need to reverse the sign. So if we multiply it through by x squared here, I'm going to get x squared minus 12, all divided by x still. This is greater than x squared. Now this denominator here will cancel with one of my powers here, so I just get left with x. That'll cancel there. So what I've got so far is x lots of x squared minus 12 is greater than x squared. And now at this stage here, I want to just start basically simplifying. So I'm going to subtract this x squared onto the other side. So it's going to be x lots of squared minus 12 minus x squared greater than 0. Now at this stage here, it actually looks easiest if we just expand this and then write it as a cubic polynomial, okay? Because if it's a cubic polynomial, hopefully we'll be able to factorize it quite nicely and then just kind of sketch it and see where it's going to satisfy our inequality. So, expanding this, we get x cubed minus 12x minus x squared. And this is greater than 0. Okay, well, this is nice and easy to factorize now. If we factor an x out here, we get x squared minus x minus 12. And this is greater than 0. And then we can factorize this here, this quadratic, so we get x lots of, so that'd be x minus 4, and then x plus 3. And that's greater than 0. Now at this stage here, we've just got a cubic polynomial. You should be confident kind of sketching cubic polynomials from your A-level maths. So we'll just kind of give it a rough sketch just to see where it's going to satisfy the inequality. So let's work out kind of where it cuts through the x-axis first. So that's going to be at 0. It's going to be at minus 3 and then positive 4 here. So minus 3, it's going to cut through at 0 there and then 4. So roughly what's it going to look like? It's going to be kind of an N into a U shape, so it's going to look something like that. So going up to the minus 3, coming down at 0, and then going back up to the 4. Okay, again, mine's just a rough sketch, but it should look something like that. Now, what we want to know here is where is this above the x-axis? So, well, if you look at your x-axis, where is the kind of curve satisfying that point? Well, it satisfies it here, this point here, or that set there, and we've also got this set here. Anything greater than 4, okay? So we've essentially done the question now. All we need to do is just give the answer in set notation here. So we've used the graph to kind of identify what the set of values is. If we write this in set notation now, this is just simply going to be minus 3 to 0, okay? Because that's looking at this point here. So from minus 3 to the origin here, 0. So that's that point there. And we can also have this point here, so when x is greater than 4. So when x is greater than 4, we write that as the union of x for x greater than 4. And there we have it, okay? So it's a strict inequality, so we get quite a nice solution there. And that's that question done, so 5 marks for that. But that's quite a nice example, given that we only have the 1 on the right-hand side. We see a bit more of a tricky one later on in the video. So we move on to the next question here now. Now we're taking a look at an inequality involving a modulus sign. So the best way to kind of tackle these is to at least always sketch a graph. It kind of gives you an idea of what you're looking at and what we're trying to find. So the first thing we'll do is we'll sketch our graph. And again, it's going to be a bit rough, but as long as you can tell what's going on, that's all that matters. So, considering the modulus of x squared minus 4, what's that going to look like? Well, imagine what x squared minus 4 would look like. So it would just be a nice quadratic cutting through the y-axis at minus 4. It would be minus 2 on the x-axis and then positive 2. But we're taking the modulus of the full thing here, so we're reflecting that in the x-axis. Okay, so where it goes underneath the x-axis, it's reflected back up. So the first thing to know is it's minus 2 and 2. So that point there between them, we're reflecting it back up, because that would be where it's underneath, right? So that kind of gets reflected back up, and it's going to cut through at 4. So that gets reflected back up like that. And then obviously the rest of it would just be the regular quadratic. So that's our sketch. So that's the modulus x squared minus 4. Now let's consider 3x. So hopefully that one's much easier to draw. It's going to be a straight line coming through here is 0. So again, just going to look something like this, just to give an idea. Something like that. Again, don't have to be perfect. Again, we're just kind of doing it to get a better idea of the problem. So what we're looking for here is where is our modulus, or the graph of this modulus function here, where is it above the line y equals 3x? Well, hopefully you can see now, at this point here, that would satisfy it. Where else would satisfy it? Well, basically anything above here now, from here to here, that also satisfies it as well. So up to like this part as well, because that's all above the straight line there. Okay, but obviously if you're looking at this point here, it's underneath the straight line, so we don't want that solution there, for example. So everything here, obviously to the left of that, and then everything greater than this point here. So to solve these modulus sketching questions like this, we have to consider basically two scenarios. So we need to consider the positive argument and the negative argument. So what do I mean by that? Well, consider x squared minus 4 is equal to 3x. Let's consider the positive argument first. Well, subtract 3x off both sides here, we get x squared minus 3x minus 4 equals 0. Factorize this now, we get x minus 4 and then x plus 1. And that's equal to 0. Okay, so what do we get here when we solve this? We're going to get x equals minus 1 and x equals 4 there. Okay, now we're only interested in actually 2 points here. So what are we interested in? Well, we're interested in where it actually intersects. So where does it intersect? So it intersects at that point there. So marking that down on the x-axis, so it cuts here. So we're interested in that point there. And we're also interested at the other point where it intersects, which is here. Okay, so again, marking that down. What we're looking to find is the coordinates of these 2 points here. Because once we've actually got them coordinates there, we can write our set of solutions nice and easy. So, essentially, with this being a positive x solution here, we can omit that negative one here, so we don't need that. So we're only interested in x equals 4. So x equals 4. And now consider the negative case. So consider, so it's going to be minus x squared minus 4 is equal to 3x. So we can easily get rid of this minus by dividing through by minus 1, for example. Or times it through by minus 1, doesn't matter which way you do it. So we get x squared minus 4 is equal to minus 3x. With enough practice, you can just go straight to this line here. Okay, so solving this now, making it equal to 0, we get x squared plus 3x minus 4 is equal to 0. Factorize again, we just want to obtain the positive x solution here. So this will be x plus 4 and x minus 1 is equal to 0. So that gives us 2 solutions again, but we only want the positive one. So this would be x equals minus 4, which we don't want. That would be over on this side here. So we only want this one here, so therefore x is equal to 1. So notice that this has to be this one here. So that's x equals 1 there, and then that one must be the 4. Now, basically, what we've discovered is that everything to the left of 1, when x equals 1 here, everything to the left of it satisfies the inequality. So the first solution here, we can write that as basically x being less than minus 1, less than 1, so x less than 1, or everything to the right when x is 4 will also satisfy it, because again this curve will keep going up, the straight line will keep going up like that, so it'll keep being satisfied. So therefore x being greater than 4 would also satisfy the inequality. So that satisfies the modulus of x squared minus 4 greater than 3x. So hopefully that kind of makes sense. We were basically requiring x greater than b, which would be that point there, and then x less than a. So hopefully that makes sense. If there's any issues though, if I'm basically explaining anything that's not very clear, please do leave me a comment below. I'll try my best to explain it. This question now, again, very similar to the second one we did, where we're solving it algebraically, but this time a little bit more difficult, because the right hand side of this inequality here, we have this x minus 3 in the denominator. So it just makes life a little bit more tricky, but nothing too crazy. So let's just write it out. So here now, like we always do, we multiply through by the denominator squared. Okay, so let's just do the left hand side first, so this inequality. So it's going to be x plus 1 times this squared and then times that squared. Times that squared. And then we still have this denominator here. Like so. Considering the right hand side of the inequality now, we're going to times through by this squared and this squared. Okay, so it's going to be 2x minus 3 squared multiplied by x minus 3 squared. But we still got our denominator here as well, so x minus 3 in the denominator. Okay, so that's kind of the first step to help us tackle this problem. Now at this stage here, like you can always do, we can start simplifying straight away. So one of those 2x minus 3's in the numerator will cancel with the denominator, so that cancels there. We also have the same with this right hand side here. We've got an x minus 3 in the denominator, and we've got 2 lots here in the numerator, so we can cancel 1 like that. So let's just rewrite what we've got here now. So we've got x plus 1 times x minus 3 squared, sorry, times 2x minus 3 times x minus 3 squared. Like so, and then this is less than 2x minus 3 squared times x minus 3. Okay, so at this stage here now, we just need to manipulate this and get it in the correct form. Well, the first thing I want to do is I want to get this being less than 0. Okay, so if I subtract the right hand side off here, so what I'm going to get now is x plus 1 times 2x minus 3 times x minus 3 squared minus this right hand side now, so minus 2x minus 3 squared times x minus 3 being less than 0. And now at this stage here, the best step to do, rather than trying to expand things, because things will get messy, is to just try and factorize. So have a look what we've got across the full expression. So I've only got 1x plus 1 here, so I can't factorise that. I've got a 2x minus 3, and I've got 2x minus 3 squared here, so that's good. And then same again, I've got x minus 3 squared, and an x minus 3. So I can factorise 2x minus 3 and x minus 3, like so. Okay. Now let's consider what we do when we factorise this. So what would I have to times 2x minus 3 times x minus 3 by to get this expression here? Well, I'd have to times that by x plus 1, because we still need that. And what else we're missing? We're missing another lot of this x minus 3. So that's an x minus 3 there, like so. And then what would I have to times this by here to get this expression here? Well, simply we're just missing a 2x minus 3, so we need to times it by that, like so. And this is all less than 0. Okay. At this stage here now, simplify this square bracket. So imagine you used to expand this and then simplify this. So expand that and then subtract this. So what would we get? Well, this outside expression here will just remain the same for now. In here, once you multiply this and subtract this, what you should get is x squared minus 4x. Okay. And this is still less than 0. And then at this stage here, just to make life a little bit easier, factorise this final expression here, so this x squared minus 4x. If we factor an x out, so we'll have an x at the front, 2x minus 3 times x minus 2 times x minus 4. less than 0. So what we have now is a quartic graph, a quartic polynomial. So we need to try and sketch it. We don't have to, but it will help basically find the set of values that we need much easier. So do it over here. What will we do here now? So let's consider where it's going to cut through the x-axis. So first point will be 0. It's going to cut through at 0. It's also going to cut through at 3 over 2. So let's just say that's there. 3 over 2. It will cut through at I've messed up somewhere. I should have a 3. That should be a 3, sorry. That's just a 3. And that's a 3 there. So yeah. So it cuts through at 3. And then it will cut through at 4. Okay. So now we know where it cuts through. We can just draw a rough sketch of this quartic polynomial. Remember, it's a quartic, so it's going to start up in, it's a positive quartic, so it's going to start in the top left here, and it will finish in the top right up here. Okay. And if you want to get an idea of roughly how it's going to look, just put a couple of x values in your calculator. So if you put x equals -1 into this expression here, what you will get is, I believe it's 100 off the top of my head. So it's quite a large value, so obviously you can't really sketch it, but it's going to look something like this. So it comes all the way down here, cuts through at 0, down, up through 3 over 2, comes back down to the 3. We have a minimum here, and it goes up through the 4 like so. Okay, so it looks something like that. Now we want to know where this is less than 0. So where is it below the x-axis? Well, we've got two sets of solutions here. We've got this point here and this set here. So all we need to know is just give this answer in set notation. Okay, well, so in set notation, just reading it off from the graph. And again, it's a strict inequality. So what do we have? Well, it's going to be between 0 and 3 over 2. So every point there between there satisfies the inequality. Or we also have this point here between 3 and 4. Okay, so I'm kind of going to run out of room, I think. Let's try and do it. I'm going to run out of room a little bit, so let's see if I can fit in. Okay, I'm running out of room. Let me just scroll some of that off just so we can see it perfectly. Okay, so that's my final answer there. So we have x being between 0 and 3 over 2, or x is between 3 and 4. Okay, so that set notation there gives us our final answer for the answer to the inequality. So that's that question done. And now we move on to the final question, another inequality question involving modulus signs. So we're asked to use algebra this time. Now, just because it says use algebra doesn't mean that you can't use a graph. I would still always recommend using a graph to get an idea of the problem. And that's what I'm going to do to start off with. So for question 2 here. Before I do it though, let's just see if we can factorize this 3x squared minus 19x plus 20. Well, we can actually factorize that. Does go quite nicely. So that would be 3x minus 4 times x minus 5. And this is less than 2x plus 2. So I can actually sketch this modulus here. So let's do that. So again, it's the modulus of the full expression, so it's going to be reflected in the x-axis, so anything below it is above it now. So again, it's just a quadratic, so what we'd expect is the part that goes underneath here will be reflected back up. So the first question is, where does it cut through the x-axis? Well, it's going to cut through at, it's going to cut through at 5 here, and it would also cut through when this is 4 over 3. So if we say that's kind of there, 4 over 3. That's that point there. So now we know where it'd be underneath, so that would now look like that. Okay, and then the rest of it obviously is just your regular quadratic. It'd cut through at 20 when x is 0, so that's going to be 20 there, for example. So it'll look something along them lines, and again going back up like that. We also need to consider drawing or sketching y equals 2x plus 2. So where's that going to cut through? Well, that's going to cut through the x-axis at -1, and it's going to cut through the y-axis here at 2. So if you draw a sketch, again, make sure yours looks a bit neater than mine, but it should look something like this, for example, okay? Something like that. So now, what we're looking for is basically, where does, so let's just write in which one this is, so that's 2x plus 2. Run out of room here a bit, and then this is the cube, the modulus. Okay, so that's the curve here. So basically, just like we did before, we need to consider two arguments. And why do we consider two arguments? Because what we're looking for here is where does basically my modulus graph here, where is it underneath the straight line? Well, if we actually look at it, again, my sketch is kind of bad, but this should be over this basically here. Okay, so the only points that actually satisfy it, so if I draw it in a different colour just to make it a bit clearer, well, we've got this point, so we'd have here to here. At this point here, my actual what's it called, my modulus graph here is below it, so that satisfies it there. And again, from here to here, it's also underneath. So my graphs are quite bad. It definitely helps if you draw a better graph than I have. So if you draw it actually quite nice and clean, it should be a lot easier to kind of illustrate the problem. So we need to find those two sets here. Well, how would we do that? Well, what we need to consider is the points of intersection, because what we want to work out is this point here, A, B, C, and D here at the end. Okay, if we can work out each one of them, we can just set it up as an inequality then between this point here, between A and B, and then between C and D. Okay, so if we can work out those points, we've done the question. So to do that algebraically, we just need to consider, again, both arguments. So consider both arguments. So what do we mean by that? Well, we'll consider the positive argument here, so that's going to be 3x squared minus 19x plus 20 is equal to 2x plus 2. So if we solve this now, we'd subtract 2x plus 2 off both sides. So that gives us 3x squared minus 21x plus 18 equals 0. So to make life just a bit easier here, you can divide through by 3 if you'd like. So that's going to give us x squared minus 7x plus 6 is equal to 0. And then if you factorize this here, this would be x minus 6 times x minus 1 equal to 0. So therefore, we've got two solutions here now. So x is equal to 1 and x is equal to 6. So we've got two of the points here. So we just don't know which one will match up yet. What we would expect is A is probably the 1. That seems quite small. And the 6 is probably going to be the D. That's what we'd expect at this point here. So now, if we consider the negative argument, we should hopefully work out B and C. So now consider the positive case, the negative. The negative argument. So what would that be? Well, that's essentially just going to be our 3x squared minus 19x plus 20 being equal to the negative of this, because if we'd have the minus here and we divide through by the minus 1, it just ends up on this side. Like so. And then at this stage here, just solve it by setting it equal to 0, and then just hopefully factorising. So that's going to give us 3x squared. We should get minus 17x plus 22 this time, so plus 22, and this is equal to 0. And then at this stage here, we can't actually factorise this. It does factorise quite nicely. We get 3x minus 11 times x minus 2 and this is equal to 0 now. So again, we've got two more solutions here. So what we obtain now is that x is equal to 2. And we also obtain that x is equal to 11 over 3. So essentially at this point now, we just need to match up which one's which. So look at your 4 x points here, so x coordinates. Which one's the smallest? Because that has to be a, right? Well, x equals 1 is my smallest, so we'd expect a to be 1. Well, we don't expect it, we know it's a equals 1. The b must be the second smallest out of all of these, which again, if you look at your 4 points, that's just x equals 2. C now, basically, is either 11 over 3, because that's all we've got left, or the 6, because again, that's the only other point we have left. Well, 11 over 3 is smaller than 6, so C must be 11 over 3, and then finally that just leaves us with D being 6. So, we've done all the hard work now, now we just give the solution. So, therefore, if it's between A and B, then we just write that as x being between 1 and 2. Like so. So that's that point there, or that set of solutions there. And then finally, we've also got between C and D. So we can write that as 11 over 3 and between 6, like so. Okay. So there we have it. So 6 marks for that if you can get to this very last stage down here at the bottom. So I hope this video's helped, guys. I hope it's not been too long. It's definitely much easier if you're sketching it yourself. So I would recommend, if you're walking through these questions with me, do your own sketches, because you should be able to see it a lot better than my terrible graphs that you can see here. They're not very neat at all. But if there's any issues, if you notice any mistakes, please just let me know down below.